Looking at this problem, what do we have here? Besides the obvious wood hammered together with nails, framing. What do we have? What? We have a triangle. Do we have just a triangle? A right triangle. Do we have just a right triangle? What else do we have? Yeah, we have a whole bunch of right triangles. Technically, we also have a whole bunch of trapezoids too. There's all kinds of stuff going on in this little figure here. But the big important thing is we have a whole bunch of right triangles. Okay, and each one of these right triangles, because they're right triangles, shares that angle right there, plus the fact that they have a right angle here, 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 and here. From geometry lets us say that these right triangles are all what? They are not equal, they are similar. They're all similar right triangles, and because they're similar, that means that I can use proportions. The length of the long height divided by the length of the long length is equal to the length of, let me do this one right here. This length divided by this length. We should probably figure out how long each one of these things is here. What? How'd you get 2? Well, how do you know that it's all equal lengths? Good. You mark off 4 equal intervals. So this length is the same as this, is the same as this, and is the same as this. If the total length here is 8, then each interval must be 2. So this length here is 2, which makes this length 4, which makes this length 6, because the overall length is 8. Agreed? Okay. So the easiest one on this figure is the middle one, actually, it turns out. Let me do the middle one first. I have the long height divided by the long triangle length. 6 divided by 8 is equal to the middle triangle height, which is how much? I don't know. It's x. That's what I'm looking for. Divided by how much? 4. I have no idea. It's lucky. So how do we solve proportions? How do we solve this proportion easier than cross multiplying? How do we get x by itself? Multiply both sides times 4. Cross multiplying does get the job done, but in this case you don't have to. Just multiply both sides by 4. And that gets x by itself on the right equals 4 times 6 is 24. 24 divided by 8 is 3. So this height right here is 3 what? Feet. They're giving us the units in feet, so it's 3 feet. So now that we know that one, we can figure out the other two. Set up a new proportion. Go back to the original. We have 6 over 8. The long height divided by the long length equals what? X over 6 or 2, doesn't matter. Whichever one you want to find first. I'll do 6. Now what do I do? Oh, again, you don't have to cross multiply. Don't make more work for yourself than you need to. Just multiply both sides by 6 to get x by itself. 6 times 6 is 36. So I have 36 eighths, which probably reduces 9 halves. So 9 halves feet. In other words, in terms that we understand, 4.5 feet. 4.5 feet. So that takes care of the longer one. Now let's do the shorter one. Set up a new proportion. Now what? I do what? Multiply both sides times 2. And I get x on the right equals 12/8 on the left. Reduce that and you get 3/2. So x equals 3/2 feet. In other words, 1.5 feet. Four and a half feet, 3 feet. That answers the problem. Cross multiplying is how you can solve proportions, but you usually only use it if I had 8/6 equals 2/x. In this case, I have the x in the denominator, which is a bummer. If you know your properties of proportions, then you know that you can interchange these two. You can interchange these two. You can flip both. You can multiply both sides by -1. You can do all kinds of things to proportions. If I had this thing set up like this, I would flip it and then just multiply both sides by 2. If you cross multiply, you get 8x equals 12, and you wind up with x equals 12/8. The exact same thing we wound up with here. It just takes one more step. Okay? All right, this section is about direct variation, which is something that we covered pretty heavily in Algebra 1, so hopefully this is just totally a review for you guys. Direct variation equations look like y equals kx. What is y? It's a variable. What is x? It's a variable. What is k? K is a constant, and we call it the constant of, anybody remember? You probably had it as a vocab word, somebody in here. Constant of variation. Constant is spelled with a C. Notice that I spelled it with a C. So, maybe we're Russian today. We have direct variation when y varies directly with x. What that means when y varies directly with x is that they are proportional. So if I can set up a proportion that compares y and x, and that proportion is always true no matter what I'm comparing, which y and which x I'm comparing, as long as they're all ordered pairs, then that means that they are direct variation. If I compare and I don't get proportional situations, then they are not direct variation. So for example, determine if the function shows direct variation. If it does, determine the constant of variation. What I'm going to do is see how much x changes and compare it to how much y changes. How much does x change in that first one? By 2. How much does y change? Okay. How much does x change in that second one? 1. How much does y change in that second one? By 2. So, if I compare how much y changes divided by how much x changes, I get 4/2. If I compare on the next one, I get 2/1. Are these two comparisons the same? In other words, can I put an equal sign here? Yes. That means that these relationships here, these two things here, are proportional to each other, which means that we have direct variation. So the answer is yes. The constant of variation is going to be whatever this ratio is that you just made. 4 divided by 2, or 2 divided by 1, which is what? It's just 2. It reduces down to 2. So k, the constant of variation, equals 2. There's your answer. Go ahead and do the second one. How do you know that the answer is no here? Over here it goes 1, and here 1. So since this is the same both times, we should see the same change over here both times. And here the change is 4, here the change is 3. So I don't even need to set up the ratios, but if I did, it'd be 4 over 1, 3 over 1. Those are not equal, so this is not direct variation. Because I got no, do I need to find k? No. So the answer is just no there. So now what we're going to do is we're going to look at equations, not tables, and determine whether we have a direct variation situation. Remember that direct variation looks like y equals kx. So if I can get the equation to look like y equals something times x, and that's it, nothing else, then it is direct variation and I can figure out what k is. K will just be the number in front of x, that's it. So for the first one, I don't have exactly y equals kx, but can I do something to make it y equals kx? Yeah, what can I do? Yeah, divide both sides by 3 to get y by itself. Basically, we're just solving for y here. Y equals what? You can write it as 7/3 times x. Is this direct variation? Yes. So it says determine whether y varies directly with x. The answer is yes. If it does, determine the constant of variation. So k equals 7/3. How about the second one? What should we do? Well, I want to get it to be y equals something, right? So I got to do what? Divide by 7. And we are switching from dividing the whole thing here by 7 to dividing every little piece by 7. When I do that, I get y equals what? Okay, is that direct variation? No, why not? Because we got this plus 1 hanging out over here, which we can't have. It's just y equals kx, not plus something else. So this one is no, not direct variation. All right, try the other two. For 5x plus 3y equals 0, what should we do? I don't speak yawn very well. Subtract 5x from both sides. 3y equals negative 5x. Now what? Divide by 3, and I get y equals negative 5/3 x. Is this direct variation? Yes. K equals negative 5/3. How about the last one? Yes or no? How many of you think yes? One person. 2 people. How many of you think no? 3 people out of a classroom full of 19 people. How many of you are thinking at all? 4 people. Excellent. Is this direct variation? It's supposed to look like y equals kx, right? Do we have y equals already? So is there any math that I need to do to get this in y equals kx form if we can get it there? No, there's no math. So the only question is this direct variation? And the answer is yes. Can somebody tell me why? So what does this actually say right here? Y equals what? What? 1 what? That's what that says. Get used to the fact that you can write x over 9, or you can write 1/9 x. If I had a 3x over 9 there, that's the same as 3/9 times x. This is direct variation. What is the constant of variation? So k equals 1/9. There's your answer. If you voted yes, good job. Up next, direct variation. Suppose y varies directly with x. As soon as you see this phrase right here, suppose y varies directly with x, that is your indication that you're dealing with y equals kx. You're dealing with direct variation. That's the clue. Then they tell you one particular point for this direct variation equation. Y is 9 when x is negative 15. That means that you can take this information right here and you can plug it in to this equation right here and figure out what k is. Once you figure out what k is, then you have the actual direct variation equation. And once you have that, then you can find any value they throw at you. What is y when x is 21? Who cares? I'm going to plug the 21 in here. I have my k, simplify it down, and I'll have my answer. They can throw anything at you once you have that equation. And that's what I'm trying to tell you here. To solve this type of problem, set up the direct variation equation y equals kx. So, we're going to write y equals kx. Then step 2, plug in what you know and solve for k. What we know is this stuff here. Y is 9, x is negative 15. So I'm going to write 9 equals k times negative 15. Plug in what you know, and then solve for k. So how can I solve for k here? Divide by negative 15 to both sides. When I do that, I get k equals, I got negative 9/15, which reduces down to negative 3/5. So now I know what k is. That's all of step 2. Step 3, rewrite the equation with your answer for k. So I'm just starting over. I'm rewriting my equation, y equals kx, but now that I know what k is, I can write it. Y equals negative 3/5 times x. Step 4, plug in the final number and solve for the other variable. So the final number in this case, they said, what is y when x equals 21? So that means that x is going to be 21 here. Y equals negative 3 over 5 times 21. Simplify that down. Y equals negative 3 times 21 is what? So you get negative 63/5. Does that reduce? Nope. So that's the answer. Let me go back over this problem so I can show you where these steps occurred. Set up the direct variation equation y equals kx. That's right there. Step 1. Step 2, plug in what you know and solve for k. That all right there was step 2. Step 3, rewrite the equation with your answer for k. That's step 3 right there. Step 4, plug in the final number and solve. That's step 4. That's how you solve these problems. It's the same thing every time. They're going to give you a piece of information. You find k with it, and then you take whatever other piece of information they give you and solve for the other variable. All right, same type of problem. Talk me through this one. What do we do first? Why am I writing y equals kx? How do you know that you're supposed to? Yes. Y varies directly with x. That is my clue. Then I'm going to go y equals kx. Now what? The information that I'm given, y equals 15 when x equals 3. I plug in what for y? 15 equals k times 3. Now what? Solve for k, divide both sides by 3, and you get what on the left? 5 equals k. Now what? Y equals kx can be rewritten now using my k. Y equals 5x. That's our equation. Now, at this point, it doesn't matter what number they give us. We can plug it in and solve just the same no matter what. So, what number did they give me to plug in? 12 goes where? It's x equals 12, so I'm plugging 12 in for x. If it said y equals 12, then I'd plug 12 in for y, and then I'd solve for x. But we have y equals 5, parentheses 12. Y equals 60. There's our answer. These problems are easy if you follow the procedure the whole time. Stick with this procedure. The salesperson's commission varies directly with sales. So right off the bat, hopefully you have some sort of signal flare going up in your head that says, I'm going to use what? Y equals kx. How did you find that? Yeah, it says varies directly with sales. So it's a story problem, but it's the same idea. I already know I'm going to use y equals kx. The only issue is I have to figure out what's y and what's x. A salesperson's commission varies directly with sales. That's kind of like y varies directly with x, right? So the way that that's worded leads me to what's y? This is y, and this is x. You have to make that analysis first. Once you've done that, then this problem becomes fairly simple. All right, so what information did they give me? $1,000 in sales. Commission is $85. So what variable is this $1,000? And then the $85 is, so I'm going to write 85 equals times 1,000. And from here on out, the problem is the same as what we've been doing. Divide both sides by 1,000. K equals 85,000, 1,000ths. 17 over 200. Gotta love technology. Now what? Okay? Now what? That's x. Because again, remember that sales is x. We have 2,300 in sales. That means that we're getting a variable or a value for the x variable. So I'm going to write y equals 17 over 200 times 2,300. And since we use technology to get 17 over 200 so easily, just plug that into your calculator. Hit Control Enter so that it gives you a decimal, because this is a story problem and we want an answer that makes sense to us. Y equals 190 or 195? And 50 cents. So I need to finish this problem. I'm not done here. What am I missing? $195.50. What is the commission? That much. If you get a job with commission and you sell a TV for $2,300, you'd be making an additional about $200 that day. It's kind of nice working on commission. All right, the last little bit for this section. The graph of a direct variation equation. Do we remember this from Algebra 1? No, but we are talking about graphs. The graph of a direct variation equation always does something in particular. Always does what? Always goes through something in particular. What? The origin. If it's direct variation and you graph it, it will go through the origin every single time. All direct variation equations have graphs that are lines. Nice. They're all lines. Notice I did not say straight lines. Why not? Are there any lines that are not straight? Is that a line? How do you know that it's not a line? Are there any lines that are not straight?
Yes. No.
Are there any lines that are not straight? What is the definition of a line? And? It's straight. If it's not straight, then it's not a line. It's a curve. It's either a line or it's not a line. It's a line or it's a curve, okay? You don't say straight. It's just a line. All direct variation equations are lines, which means it's straight.
So why did you just put straight in the first place?
I didn't.
Why not, though?
You don't need to.
It would have stayed right now.
Graph the following direct variation equations using a table of values. We know that this graph is going to go through 0, 0. I'm forced to use a table of values. So I'm going to put 0. And what would my y value here be? 0. Now I need to pick some other numbers because we can't graph a line without more than one point. So I could do 1, 2, 3, 4. What's the problem with that? It's not easy, actually. Those are easy numbers, but they're not easy numbers to work with in this problem. Why? Because we have that fraction. So let's pick smart numbers, easy smart numbers, which would be numbers that are divisible by 4. So how about 4? And maybe we could go 8, we could go 12, 16, but we could also go -4. Easy numbers do not necessarily mean 1, 2, 3. If I plug in 4, what do I get? 3. If I plug in -4, what do I get? Okay, so now we have 3 easy points to graph. We have 0, 0. How do I get that? I plug in 4. I have 3 times 4 divided by 4. I have 4, 3. So 4, comma, 3 is right there. And then I have -4, so to the left 4 first, and then down to -3. Does that look like it's probably a line? Yep, so then we're going to draw in what kind of line?
Straight.
Which means you're going to need to have a ruler or something that is straight, like the side of your planner, your driver's license, a credit card, anything that is straight. I need to see straight lines. If it's not straight, it's not a line. And all direct variation equations are lines when you graph them. All right, table, x, y. What should we probably put in that table? 0, 0. What else should we put in that table? What? -4? 1? And? You could go -1. You can go +2. There's no fractions involved in this one, so this time easy numbers are easy numbers. If I plug in 1, what do I get? -2. If I plug in 2, what do I get? -4. You could also pick numbers that are farther apart. That will give you a better looking graph when you're done because your points will be farther apart. So 0, 0 is on the graph. 1, -2 is on the graph. 2, -4 is on the graph. It does look like a line, so let's make it look like a line when we graph it. Very carefully line up your ruler and draw on your line.